Hi, it's MP the tutor again. And today we're going to look at surds and square roots and also link into what's called prime factors. So let's start off with looking at surds. So if I have the square root of 2 times the square root of 2, well, that's the same as the square root of 2 times 2, which is the same as the square root of 4. And the square root of 4 is 2. And the square root of 5 times the square root of 5 is the same as the square root of 5 times 5, which is then the same as the square root of 25, which is 5. So if you have two square roots which are the same multiplied together, that just turns into that thing. So for example, if I have the square root of sheep times the square root of sheep, well, that's the same as the square root of sheep times sheep, which is the square root of a square sheep, which is just sheep. So let's have a little wander through adding. So if I have x plus x, well, what does that equal? Well, that equals 2x. And if I have 3x plus 4x, well, that is 7x. And let's go 11x minus 8x is 3x. Well, let's have something quite similar. I'm going to do the square root of 3 plus the square root of 3. What's the square root of 3 plus the square root of 3? Well, it's the same as x plus x. That is 2 square root of 3. And let's go for 3 square root of 13 plus 4 square root of 13. Well, exactly the same as last time. 3x plus 4x is 7x. 3x plus 4x is 7x, or 7 square root of 13. And let's go for 11 square root of sheep. Call that my sheeps. Minus 8 square root of sheep. Nice and easy to draw. Well, then that is 3 square root of sheep. So adding and subtracting of surds is a bit like adding and subtracting of algebra. So you may have done prime factors at GCSE. Let's have a quick look through this again. So what we do with prime factors, these are like prime numbers which make up another number, and we split this up into prime numbers. So effectively, we're going to do 48 divided by 2 is 24. And what we're doing is we are splitting up our 48 into smaller prime numbers which will multiply together. So 24, then that halves to be 2 and 12. That halves again to be 2 and then 6. That half again to be 2 and 3. And I like to put a nice big loop around these things. So 48 is 2 times 2 times 2 times 2 times 3. Or 48 is 2 power 4 times 3. Let's zoom in a little bit. And let's have a little look at the square root of 48. So here we have square root of 48. Do the same thing. 2 and 24, 2 and 12, 2 and 6, 2 and 3. Woo! Well, the square root of 48 is the square root of 2 times 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 the square root of 3. Well, it's got a different colour. What is the square root of 2 times the square root of 2? Well, that is 2. Times that by another square root of 2 times the square root of 2 is a 2 times root 3. Go back to black. So here is a pair of 2's, and there is another pair of 2's. So 2 times 2 is 4 root 3. So square root of 48 equals 4 root 3. So what we're doing is we're doing prime factors to work out the square roots in a simpler way. So let's do another example. Let's go for the square root of 80. Well, we're going to do 80 and we tree it. So 2 and 40, 2 and 20, 2 and 10, 2 and 5. Put a loop around all our prime numbers. So here we have a pair of 2s. Here we have another pair of 2s. So that's like going 2 times 2 times root 5. 2 times 2 again is 4 root 5. So the square of 80 is 4 root 5. We'll write this question. Well, here we have the square root of 108 plus the square root of 75. And what we need to do is we need to prime factor 3, both of them separately. So you have 108. Half of 108 is 54. Half of 54 is 27. Now this doesn't divide by 2, but it does divide by 3. So you get 3 and 9. And then we have a 3 and a 3. Then we're going to do the same for 75. We're going to straight down go for 3, may as well, and 25, and a 5, and a 5. Now, in theory, you don't have to go in the exact same order. You could have done 3, or 5, and 15, and that way around. But that's fine. So, we're going to look at the first one, and we have a pair of 2s. Gets us a 2. So that's a 2 times by another 3 times root 3, which gets you 6 root 3. Here I just have a pair of 5s, which gets you a 5 times by root 3, which is 5 root 3. So what we have is we have 6 root 3 plus 5 root 3, which is 11 root 3. So what we're doing is we're going to simplify down these big prime factors, or big numbers, into smaller numbers via prime factors. So here we have square root of 600 minus the square root of 96 equals the square root of k. Find k. So if we have something like 600, what can be quite easy, first of all, is we're going to split this up into 6 and 100. So if you can spot these ones like 6, 100 is 6 times 100, and then we can split the 6 into 2 and a 3. And the 100, I split into 10 and 10. So there's nothing wrong with splitting these up into things like that. I'm going to put a loop around our prime numbers. We could then work out our prime factor pairs. So for example, we have a pair of 2s and a pair of 5s. That gets you 2 times 5. And then what's left is times the square root of 2 times the square root of 3. If I make that a bit smaller, therefore we have 2 times 5 is 10. So that gets you 10 root 6. Then we're going to go for the 96. Tree that. So that can get you 2 and 48. 2 and a nice 24. That gives you 2 and a 12. 2 and a 6. A 2 and a 3. These are our prime numbers, so all around that. And of course we have some pairs. So we're going to have a pair of 2s. We've got another pair of 2s. We have then times root 2 times root 3, which gets you 4 root 6. So we have 10 square root of 6 minus 4 square root of 6 is 6 square root of 6. Now, if we look at this question, though, I want it as a single square root of k. Well, 6 square root of 6 is the same as the square root of something times the square root of 6. Now, 6 is the same as the square root of 36. And then we end up having to do 36 times 6. So you could use a calculator for that. You could use Gridway or any other way for multiplication. So that gets you the square root of 216. Boom. So k in this case is 216. So let's have a little look at expanding brackets with surds. So here's an example where we have to expand this bracket here. And it's basically the same as with normal expanding brackets with algebra, but we have now got surds. So what I'm going to do is I'm going to do a little grid. We have root 3 times by 2 and square root of 3. 2 times root 3 is 2 root 3, and root 3 times root 3 is 3. So what you end up here getting is 2 square root 3 plus 3. So this next one is very similar to the last one, but we have a little bit more to our square roots. So we're going to do the same multiplication grid, and we have 2 and 4 root 5 and 3 root 5 there. So to start off with, we have 3 times 2 is 6 square root of 5. Now, the next one, sometimes I find it easier writing a little sum. So we have 3 times 4 is 12, and square root of 5 times the square root of 5 is 5. So that is 60. So 12 times 5 is 60. And then we just kind of add it. So you have 6 square root of 5 plus 60. So this time we have 2 bits in each of the brackets. So we're going to have 2 lines and 2 lines in opposite directions. We have 2 and square root of 5 and 3 and square root of 5. It doesn't matter which way around you have them, but let's carry on. So 3 times 2 is 6. We're going to look at this next one over here. So 3 times root 5 is 3 root 5. 2 times root 5 is 2 root 5. And root 5 times root 5 is 5. What you'll find is that there'll be kind of a pair of numbers sometimes and a pair of surds or square roots. So what we end up having is 6 plus 5 is 11, and 3 root 5 plus 2 root 5 is 5 root 5. So what about this one? Well, this is basically exactly the same, but with slightly more annoying numbers. So we're going to have 4, 2 square root 11, and 5 and 3 square root 11. We're going to start in this one. 4 times 5 is 20. 2 times 5 is 10 square root 11. 4 times 3 is 12 root 11. And here, this is a little bit of a fiddly one. So here we have 3 times 2 is 6. And the square root of 11 times the square root of 11 is 11. And 6 times 11 is 66. So we have like 20 plus 10 root 11 plus 12 root 11 plus 66. We add our terms together and we get 86 plus 22 root 11. So why don't you have a little go now at some of these questions on the screen. So this comes from the textbook, and it's a bit of adding surds and then also expanding brackets. And pause the video now, and I will then put the answers on momentarily. So hopefully you've now paused the video, had a go at the questions. As you can see, the answers are on the screen. And on our next video, we're going to be looking at rationalizing surds. So hopefully you find that really useful, and enjoy the next video.